Let us consider this problem 2151. The jet transport B is flying north with a velocity VB 600 kilometers per hour. So that's actually the speed. When a smaller aircraft A passes underneath the transport headed in the 60 degrees direction shown. To passengers in B, however, A appears to be flying sideways and moving east. Determine the actual velocity of A and the velocity which A appears to have relative to B. Okay, so let us read the problem again carefully. The jet transport B is flying with a velocity, flying north with a velocity VB 600 kilometers per hour. So let me just put Cartesian coordinates here. So then VB is just 600 EY kilometers per hour. Let's just convert to meters per second. Okay, so VB is traveling north with this speed. When a smaller aircraft A passes underneath the transport headed in the 60 degrees direction shown. Okay, so VA, we have its direction. It's some magnitude along cosine 60 degrees EY plus sine 60 degrees EX. Okay. To passengers in B, however, A appears to be flying sideways. So to passengers in B, to observers in B, A appears to be flying sideways and moving east. So like seen here. Determine the actual velocity. Okay, so the two observers in B, A appears to be flying sideways. This means that the velocity of A observed from B, A with respect to B, which is VA minus VB, has a certain magnitude and is going east, so along EY. So then I can write, replacing VA by its expression from here, VB by its expression from here, to say that VA cosine 60 degrees EY, plus sine 60 degrees EX minus 600 over 3.6 EY is equal to the magnitude of VA with respect to B, VA minus VB EY. Now this is a vector equation in 2D and it has two unknowns. So one vector equation in 2D, which is two scalar equations, two unknowns, we can solve. I can take the products with EX and EY and I can solve for the unknowns. Oh, I made a mistake here. So that's going east, so along EX. And VA sine 60 degrees is equal to 600 over 3.6. Okay, so I can solve for VA first from here, and then I can get VA with respect to B from this equation. And let me give you an analogy to this problem. Hopefully that will help you understand it better. So consider this the top view of a bus. So the bus is going like this. This is the velocity of the bus. And say that there's a person that is sitting on the bus. Maybe I should draw a chair. So they're fixed on the bus, and then there's another person that's walking on the bus. Say they're going sideways. EX, EY. Okay, so this is person A and this is person B. The velocity of A is equal to the velocity of the bus because A is fixed to the bus. So the velocity of A with respect to the bus is 0. Now, the velocity of B with respect to the bus, which is the velocity of B minus the velocity of the bus, is gonna be something along EY. So some VB with respect to bus along EY. So that an observer fixed to the bus like A, an observer fixed to the bus like A sees B moving along EY. But in reality, B is not moving along EY. B is moving along V bus plus whatever speed along EY it's going in. VB is V bus plus the velocity of B with respect to bus along EY. So hopefully this clarifies what's happening, that the same here as the observer A seeing B moving to the front, B is not actually moving to the front along EY. B is moving along EX and along EY. This the passengers in plane B see A moving sideways, but A is not actually moving sideways. A is moving the velocity of the plane plus the sideways velocity that it's moving, which means that the velocity of B of A with respect to B, VA minus VB, is sideways. Thank you.